Hey, these are notes 2.2. We're looking at different types of parent functions and then seeing what happens to the graphs. Okay, so these parent functions you should memorize if you haven't done that from Algebra 2. Okay, the parent function y equals x squared is a basic shape like this, has a vertex at 0, 0. If we have x squared plus 3, that shifts everything up 3. So that vertex, instead of being here, will be up 3 units. If it's x squared minus 2, the minus 2 shifts it down 2 units. So all the points are shifted down 2 units. So each of these points just shift down. Okay, if it's inside the parentheses, if you think about x minus 3, if you set that equal to 0, and you solve that, you get x equals 3. That's where the x is. Okay, so you think negative moves left, but it actually moves right because of how you set it equal to 0. So all these points get shifted to the right 3 units. Graph would look something like that. Same thing here with this one. If you put x plus 4 equal to 0, you get x equals negative 4. So everything gets shifted or translated to the 4 units to the left. Okay? So that's the basic idea of all these. We're just going to start with a different parent function. X to the third looks like this. Kind of think about this in the middle point there. So that middle point, and all the points actually, are being shifted up 3 and down 2 and right 3 and left 4. Okay. Start with a different parent function. Okay, square root of x looks like this. So plus 3 just shifts it up 3 units. Minus 2 just shifts it down 2 units. To the right 3 units, and plus 4 makes it negative 4 units. Okay, so we're just looking at how it shifts the graphs. Okay, now, so this does a couple different things, and then when we look at that, we're going to think about the domain and range then. So we know that the parent function is absolute value of x, which means it's a V shape. Okay, I didn't go over that up here, but absolute value is a V shape. And usually that V shape goes through 0, 0, the vertex. But here it's going to go minus 6, means down 6, and plus 2 actually means it's left 2. So my V shape is going to look like this then. Okay, so if I think about the domain, my x values, it's going to keep going for all these x's, it's going to keep going for all these x's, so that's going to be all real numbers. Think about my y, my range. My y goes down here at negative 6, and there's no values below it, but there are values above it. So our y is going to be greater than or equal to negative 6. Okay, or the way we had been writing in interval notation, from negative 6 to infinity. Okay, the next one here, also absolute value, so it's going to be V-shaped, and it's going to move up 8 and right 2. So our graph would look something like this. Our domain, okay, it's going to keep going and keep going, so all these x's and all these x's are included. And the range, okay, it starts here at 8, and I don't have values below, but I do above it. So my y is going to be greater than or equal to the 8, which means it's 8 equal to 8 to infinity. Okay. The basic function here is y equals x squared, which we talked about up here, y equals x squared. So plus 2 shifts it up 2, minus 1 shifts it plus 1, and we get our U shape there. Domain, all these x's, all these x's, so it's going to keep going and going. And the range looks like it starts at 2 and goes positive. So my y is greater than or equal to 2, or from 2 to infinity. Okay, square root. Okay, remember what that one looks like. Okay, minus 3 shifts it down 3. Minus 2 shifts it right 2. So there is that point. And it would open up like this. So domain, looks like I don't have any x values until here at 2. So my x would be greater than or equal to 2. or from 2 to infinity. Okay, thinking about range. Range looks like it starts here at -3, and then it's going to keep going up, 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 up. So y is going to be greater than or equal to -3, or from -3 to infinity. Okay, remember at any time, pause these and talk about them anytime. Okay. Number 8, we had already talked about this topic, the least squares regression line. This is where you're using Desmos, and you're going to use y1 tilde mx1 plus b. So that, we're not going to go over that again, but you can think about that idea there. And the 2000, remember you just plug in that in, and so forth. Okay. Oh, well, this is the idea. So if I'd start this at the year 2000 and 2001 versus if I started it at 0 and then 1, 2, you can see that's just a transformation of the data being shifted. Okay, I'm not going to go over that right now, though. As long as you understand these shifts, you are good with 2.2.